Alright, 2-2 is solving one-step equations. Hopefully this will be kind of review for you guys. The key thing here is there's a couple little things. The most important thing you do when you're solving equations is definitely remember that whatever you do to one side, when you apply something to one side of the equation, you must apply the same thing to the other side. And we have formally we have these properties. We have the addition property of equality, the multiplication property of equality, right? All that stuff. But if you stick to that little rule there, then you'll pretty much be fine. So let's get started solving these guys. These should be pretty much review. But the second thing actually that I wanted to say was, don't think, oh well, it's for instance this number 1. Oh well, it's added, so I have to subtract. Okay, don't think like that. Actually, try to train yourself to think like, ask yourself, what's happening to n? What's happening to n? And then the second thing you tell yourself is, okay, that's happening to n, so I need to do something to get rid of what's happening to n, right? Or I need to, and I'm going to say this a lot in class, apply the inverse operation. Apply the inverse operation, apply the inverse operation, right? And that's why we spent a little time working on inverse, right? Multiplicative inverse, additive inverse, that stuff. So let's get cracking on these. So n plus 14 here. What's happening to n? Well, n is being added. N is being added to 14, right? N is being added to 14. So I need to apply the inverse operation of addition. What is the inverse operation of addition? Well, it is addition of the opposite number, right? Addition of the opposite number. So we have a positive 14. So what I'm going to do is I'm going to take a negative 14. I'm going to have, I'll write this in green too. N plus 14. Actually, here. So give me one. Let me do this part in black, and then you'll see this is what we had originally. N plus 14. And then what I'm going to do is plus a negative 14, right? And then we have equals, of course, on the other side, equals negative 28. But we have to do the same thing on both sides. Plus negative 14. And you guys are noticing, well, why do you write plus negative 14? Why don't you just minus? It's exactly the same, all right? Exactly the same. So 14 plus a negative 14, what happens there? Well, of course, we chose plus negative 14 to cancel out. Alright, so now we have n equals, and then we have this negative 28. And go ahead and do the scratch work. I'll do it right here real quick. Negative 28 and negative 14, right? And these are the same sign, take the sum, right? So 8 and 4, okay, that's 12, right? And then we've got 2, 4, right? 42, I think that's right. Double check my arithmetic, right? But we've got negative, so now we have negative 42. Right? Alright, so that's the first one. Nope, I'll erase the scratch work because we're not using it now. How about this second one? And I went into number 2, sorry about that. Okay, let's see if we have enough room for number 2 here. Alright, so here we have negative 8 minus negative k. Alright, well that freaks me out in the first place. So whenever you see a subtraction, you can always, when you see subtraction, you can change it to adding the opposite number. Right, that is exactly the definition, basically, of subtraction, right, when we're talking about integers. So we're adding the opposite number. Okay, let's do it. So let's rewrite this real quick. Rewrite this, negative 8, and I guess, yeah, sure, we changed how it looked, right, plus positive k, right, and then this is going to be equals negative 12. Okay, so again, what's happening to k? What's happening to k? Not, do I add or subtract, right? No. What's happening to k? Well, a negative 8 is being added to k. Negative 8 is being added to k. So what do I need to do? I need to apply the inverse operation of addition. The inverse operation of addition. So that's my negative 8 that I started with. What's the inverse operation? It is adding the opposite number, right, for addition. So that's the opposite of negative 8 is positive 8. And then we had our k. I'll just keep my k here. I like to do this all in one line, even though it's like a little bit of extra writing. I'm going to run out of room on this side, sorry guys, but because it's going to save you later on when you have everything written out nicely. Okay, and then what happens? Of course, we chose that positive 8. We choose it, right? So that it cancels and we leave our k alone. We leave our k here. And then 12 and a negative 12 and a positive 8 added together. Well, their difference sign. Take the difference, right? Okay, so we can do that here in Scratchwork. 12 and 8. Take the difference. Okay. 8, 9, 10, 11, 12, right? That's 4, right? So we didn't have to do Scratchwork, but whatever. It's nice to do. And then check the sign. Which group of stuff is bigger? This one, right? So we end up with negative 4. Negative 4. That's our answer. We can box it. Let's box this guy too. Box it. Okay, and how about this one here? Okay, we've got a 16. What's this? What's happening to z? We ask ourselves, what's happening? 16 times z. Times z. So apply the inverse operation. Okay, what's the inverse operation of multiplication? Well, a multiplicative inverse, if you remember, we have 16. Let me do that in black here. But that's because that's what we started with, right? So we have 16, and we apply the inverse, the multiplicative inverse, 1 over 16, right? And multiply that. And then of course we still had our we originally had our z over here. But now the golden rule, what we do to one side we must do to the other. So this is 1 over 16 times our 2, right? And what happens when we multiply these guys together? They're not gonna cancel out to 0, right? With addition they do cancel to 0. That's why we choose that. But when we multiply these, we end up getting 16 over 16, and then times z here, right? And what's 16 over 16? Is just 1. So that's why I'm doing the one extra step here, but 1 times z, and that's just z. So I did all these steps, to show you that really quickly. That's why we're applying the inverse operation, right? Okay, and then for the other side, we get 2 over, and then I'll keep this stuff in green, 16. And that we simplify. Make sure you simplify these. So let's divide by 2 on the top and bottom. There we go. Alright, so that's going to be 1 over 2 divided by 2, right? And then 16 divided by 2 was what? Is that 8? Good. Yeah, that's 8. So z is 1 over 8. And we can box it. And 1 times z is z. Same, right? Good. Same, but different. Okay, let me erase this stuff. This is our Scratchwork from before. I don't even know why I had to do that. I didn't have to. I just, extra steps, let's make sure I'm doing everything right. So here, again, same kind of thing. What's happening to m? We ask ourselves, what's happening to m? Well, we have a negative 6 times m. So let's apply the inverse operation of multiplication. That's multiplication by the reciprocal. Now, what happens to that negative? That's the question. People will get confused about this. The negative stays there, right? Because the reciprocal doesn't change signs. When we apply the reciprocal of a number, it's the same sign, but it's just flipped over, the fraction. And then what we had here, times m, right, equals 14. What did I almost forget? I almost forgot. Again, times negative 1 over 6. I'm out of room here, sorry guys. 1 over 6. All right, and so what do we end up getting? And we saw earlier that cancels not to 0, but it cancels to 1 times m, which is just m, right? This is the thing that people get confused on sometimes. Okay, and then we have 14, negative 14, right? There's a negative 1 here, negative 1. Okay, so negative 14 over, well, I should put the negative sign in green too, right? There we go, over 6, and simplify this bad boy, and we've got m equals, what do we have? Still negative here. Negative, let's divide by 2, right? Divide by 2. I think we can do that. Negative 7 over 3. And guys, please leave it as an improper fraction. That's what you're going to work with mostly moving forward. So there you have it. That's one-step equations. Hopefully that was helpful.